serial process of getting 2D object data from the user or from the system and rendering this object to the computer screen or to the rendering screen. This total process is called as viewing pipeline. We have already covered that in our computer graphics syllabus. We have already covered that how we can create different kinds of geometrical shapes like points, straight lines, other regular geometrical shapes like circle, triangle, rectangle, square, all of these geometrical shapes, how we can create this. We know that. This is called scanline algorithms. We have studied some scanline algorithms like midpoint circle drawing algorithm or midpoint line drawing algorithm, Rosenham algorithm, all of these scanline algorithms we have already studied. Using these algorithms, we can draw, or computer or system can draw objects or regular geometrical shapes over the screen. Now, after getting the coordinate data, after getting the coordinate information from the user, using this scanline algorithm, we can draw all of these objects over the screen. Now, how these objects can be rendered over the screen or over the monitor, that is basically described in viewing pipeline technique, using viewing pipeline procedure. You can see here is a here we can see a transition, a flow transition of this total process, how from collecting data, we can render objects over the screen. As you can see, the first module is 2D object data, then object transformation. This object transformation means, as you can see here, this object transformation means the basic transformation techniques we have studied just in the previous week in our basic transformation module, that is translation, rotation, and scaling. And using these three basic transformation technique, we can create some combinational or complex transformation like reflection, sharing, bending, all of these things. Okay, so this is the object transformation. After object transformation, as you can see, window transformation, then clipping, then viewport transformation, then scan conversion, then frame buffer, then computer display. This is the total flow of rendering any kind of object from a point to a very complex image or very complex frame over the screen. This is the procedure we have to follow. Okay, so as you can see here, we have in this third module, in B module, as you can see, window transformation. So what do you mean by window and viewport? First, we have to clarify these things. What is window and what is viewport in this viewing pipeline process? So as you can see here, window is the world coordinate area for display. The explanation is what we can see by our eyes. What we can see by our eyes, that is basically our window coordinate. What we can see normally, the total scenario or the total frame we can see by our eyes, that is called the world coordinate. As much as possible the information, or as much as possible the object information we can see or we can receive, that is called world coordinate display. Okay, and what is viewport coordinate? When we are trying to render this scenario through the viewport of any device, like any kind of rendering device, like any kind of screen or any kind of monitor, or if we want to capture the scenario using any device like any camera or like any kind of camera like digital camera, SLR camera, film camera, using any device. When we are trying to capture this scenario, then the area which we are actually getting snapped or we are actually getting captured, that is called the viewport. So the difference between the window area, window display and the viewport, window and viewport, is that window is basically the superset. That means window is everything what we can see, and viewport is that clipped area, or viewport is that cropped area what we can watch through any rendering device like monitor, screen, capturing device like any kind of camera like this. So do you understand what is the difference between window and viewport? Is it clear to all of you?
Yes, sir.
Hello? Okay. So if there is any problem, you just tell me. You just raise your hand if there is any problem. Okay. So okay, so as we can see, this is the difference between window and viewport. Window is the bigger thing. Window is the superset where all the information or the total scenario what we can see in front of us, that is called the window or the world coordinate area. And from this world coordinate area, the portion what we are going to render through any device, what we are going to render, this is the most important thing. That is, this is the most important line about, this is the most important phrase about the definition of viewport. That is the area displayed on a device, the area displayed on a device like any kind of monitor, any kind of projection system, any kind of screen, or any kind of camera. So the display what we can get from any kind of devices, that is called the viewport. Viewport device or viewport area. Okay. So window is what is viewed, what we can see, what is viewed or what we can see, and viewport is where it is displayed. That is the device screen, or basically you can say the device. So this is the difference between window and viewport. So now in this viewing transformation, we will see how we can transform the objects from window, from this window or world coordinate system to viewport or device coordinate system. In this viewport, in this viewing pipeline module, we will study that how we can transform the objects or the scene from world coordinate system or window coordinate system to viewport coordinate or device coordinate system. Okay, we will see that actually how we can render the scene or the object from or through a device. That we will study in this viewing pipeline module. So this is the transformation procedure. As you can see in this image, this is the transformation procedure, viewing transformation, that is mapping a part of a world coordinate scene to device coordinate. This is called window to viewport mapping. This is called window to viewport mapping. Okay. So the part of a world coordinate scene to device coordinate or device viewport. How we can map this. As you can see in these two images, that is the first image depicted the world coordinate system. The first image depicted the world coordinate system. Now this world coordinate system has been uh, described by four coordinates. Four coordinates. As you can see, I am little bit zoom in this uh, document so that you can see more clearly. Now, as you can see here, the world coordinate which is called as the window, the world coordinate which is called as window, and the device coordinate which is called as viewport. So you can see both of these window and viewport in these two images. Now this world coordinate has been described by four coordinate system. In y-axis, you can see here yw max and yw mean. What does it mean by these two coordinates, yw max and yw mean? Yw max is the maximum y coordinate of window system. Maximum y coordinate value of window system, and yw mean is minimum y coordinate value of window system. Can you understand? Hello, all of you, can you understand?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Okay, so where you will feel some problem, you just raise your hand or you can ask the query.
Okay, sir.
Okay, so in y-axis we can see two coordinates. One is yw max, which describes the maximum y coordinate for the window, and yw mean, which describes the minimum y coordinate for window. And in the same way, we can see xw max and xw mean. It means the minimum x coordinate of window and maximum x coordinate of window. So this window coordinates will be described by these four coordinates, that is xw mean, xw max, and yw mean, yw max. Now in the same way as we can see in the viewport, in the same way if we see the viewport, we will see the same thing. YV max in the y-axis we will see YV max, YV mean, and in x-axis we will see XV mean and XV max. So like the same way, you can see here in x-axis YV max means the maximum y coordinate for the viewport, and YV mean means the minimum y coordinate of viewport. And in the same way, XV mean, it describes the minimum x coordinate of viewport, and XV max is the maximum x coordinate of viewport. Now, just look this image very carefully. Over the window system, over the window coordinate, you can see a shape. Over the window coordinate, you can see a shape. Okay, it is a kind of shape we have shown here. Now in the viewport, you have seen the shape but partially. Can you understand what I'm trying to say? Can you understand what I'm trying to say?
তাহলে ভিউপোর্ট হচ্ছে যে উইন্ডোজ সাবসেট।
Yes, that is in window system. In window coordinate, there is a shape, and that same shape we can see in viewport coordinate, but only a portion of that shape, only a little portion of that shape. This is basically the viewing transformation I am trying to tell you. That is mapping part of a world coordinate scene. As you can see in the definition, mapping part of a world coordinate scene to device coordinate. This is the viewing transformation, mapping part of a world coordinate scene to device coordinate or viewport area. As you can see here, in this window area or window coordinate, there is a shape. Some portion of this shape is outside of this window coordinate, and now when we are going to map this window coordinate to viewport coordinate or viewport area, the outside portion of this shape will be cropped. The outside portion of this shape will be cropped, and only the inside portion will be visible within the viewport area. That is the thing I'm trying to tell you. This is basically the transformation technique we will do in this window viewport mapping. Window is the total set, the bigger area what we can see in front of our eyes. And now when we are trying to transform this scenario through a device, through any electronic device like any kind of monitor, any kind of screen, any kind of projection system, or any kind of camera or capturing device, all the part of the scene what we can see is not coming into it. Only a little portion we can capture, only a little portion we can render. So this is called the viewport portion. This is called the viewport area. Here in these two images, that is trying to be shown here. In window coordinate, you can see there is a shape. There is a shape you can see here. There is a custom built shape over here, and some portion of this shape is outside of this window area. Outside of this window area. And now when we are going to transform this window area to the device viewport, we are going to transform this window area to the device viewport. We can see here this outside area which is basically not visible in the window coordinate, that has been cropped according to the device viewport coordinate, that is y vmax, y vmin, and x vmax, x vmin. Using these four viewport coordinate values, we have cropped this shape, we have cropped the outside portion of this shape, and only the inside portion has been displayed in this device viewport area. Is it clear? Is it clear to all of you? Any problem up to this, please tell me. If there is any problem up to this part, please tell me. Hello? Is it clear to all of you?
Yes, sir.
Okay. Okay, so next, this is basically the techniques. This is basically the techniques for 2D viewing transformation pipeline. We have up to till now, we have discussed about the total story of viewing pipeline, what actually we are trying to do and why we are trying to do this. What we are trying to do and why we are trying to do. That means what is window, what is viewport, okay, and why this transformation is actually required. That is we have discussed till now. Now you can see this is the 2D viewing transformation pipeline or the techniques we will follow for this transformation procedure. First, you can see modeling coordinates. That is, construct world coordinate using modeling coordinates transformation. Modeling coordinate means, as you can see here, y w max, y w min, x w min, x w max. These are the modeling coordinates depicted here. Construct world coordinates using modeling coordinates transformation. Now, from this world coordinate, convert world coordinate to viewing coordinate. Now we are transforming this world coordinate or window area to the device coordinate or viewport area. From world coordinate to viewport coordinate. This transformation has been done by transforming actually this, as you can see in this image, this window area to the viewport area. Transformation of window to viewport. That is basically the transformation of world coordinate to device coordinate. So as you can see here, from window coordinate WC to transformation to viewport coordinate or VC. Now map viewing coordinates to normalize viewing coordinates with window viewport specification, window viewport specs. Now what is this normalization procedure and why this normalization is required? When we transform any object from window coordinate to viewport coordinate, two or three things can happen. Either some part of this object has been cropped, some part of the object has been cropped to the viewport coordinate. As you can see here, this shape has been cropped into the viewport coordinate. Only a small portion is visible within the viewport coordinate or device coordinate. That is the one thing. This is a kind of normalization. The second thing is an object can be totally omitted. An object can be totally omitted from the Windows coordinate to viewport coordinate. That is, the object was present in the window coordinate or world coordinate system, but when we have transformed it to the device coordinate or viewport coordinate, this object is not present in the frame. This object is not present in the frame. That is a total deletion of the object from the frame. That is another kind of normalization. And the third normalization can be that the size, the shape, or the size, rather to say, the size of the object can be normalized. The size of the object can be normalized according to the coordinate of the viewport or device. It means that an object has its original or actual size in the window or world coordinate system. Now, when we are going to map this object into the viewport coordinate or device coordinate system, according to the coordinate of device or viewport, this object, the size of the object has been normalized. Either it will be zoomed out or it will be zoomed in. So this is another kind of normalization. Can you understand this? Is it clear to all of you? Is it clear to all of you?
Yes, sir.
Hello?
Hello.
Is it clear to all of you?
Yes, sir.
What do you mean by normalization? And why this normalization is required for this transformation to world coordinate or window coordinate to device coordinate or viewport coordinate? This is a three-way we can normalize the objects. One is the partial visibility of the object. The partial visibility of the object, that is called cropping. The total deletion of the object, which is present in the window coordinate but not visible in the viewport coordinate or device coordinate. That is the total deletion of the object. And the third one is change in shape. Sorry, not shape, change in size. Change in size of the object. That is normalized size of the object from window coordinate according to viewport coordinate or device coordinate. This is called normalization. Okay, so is it clear, or any question from up to this? Is it clear to all of you? Please tell me.
Yes,
Please
sir.
tell me, is it clear to all of you? Hello? Hello, can you hear me? Hello?
Hello.
Please respond. I'm telling you, please respond. When I'm asking you anything, please respond. Because as we can't see you, it's a virtual classroom, and almost during for this bandwidth problem, we have, all of us have just muted our video. So please respond when I am asking you anything. Please respond. Try to respond. Otherwise, I will not get that information. That is there any problem or is there any query from your side? Okay. Anyway, should I proceed? Should I proceed further? Hello. Should I proceed?
স্যার নরমালাইজেশনের ব্যাপারটা আরেকবার একটু বলবেন স্যার?
Yes, that's why I am repetitively asking you. Is it clear to all of you? Is it clear to all of you? That's why I am asking you. If you do not tell me, how I can understand? Is it okay for you or not?
Yes,
It is not a normal or physical classroom. You have to understand this. Okay, I repeat. When the normalization means, as you can see here, we are going to transform window coordinate to viewport coordinate. Okay. So now what is the process for this transformation pipeline? The process is first construct world coordinate using modeling coordinate transformations. What does it mean? The world coordinate, this is the world coordinate as I have shown you here. X W mean, Y W mean, that is the world coordinate. X W mean, Y W mean, X W max, Y W max. That is the 4 world coordinate values. Okay, 4 window coordinate value. Is this okay? Is it okay to all of you?
Yes, sir. Yes, sir.
Okay. Now we are going to transform this window coordinate to viewport coordinate. As you can see here, the coordinates of viewport, coordinates of a viewport or coordinates of a device viewport. That is X V mean, Y V mean, X V max, Y V max. That is the coordinate of a viewport. So this is the coordinate of window. X W mean, Y W mean, X W max, Y W max. These are the coordinate of a window, and X V mean, Y V mean, X V max, Y V max. This is the coordinate of a viewport. Now we have to transform one frame from window to viewport. To transform this, what the procedure we have to follow? We have to follow this procedure. First, we have to construct the world coordinate using modeling coordinate transformation. World coordinate, I have just now told you, I have just now said what is world coordinate. So convert this world coordinate to viewing coordinate. Viewing coordinate means nothing but the viewport coordinate. What I have said just now. This one is the viewport coordinate, this one is the world coordinate. So we are transforming our frame from world coordinate to viewport coordinate. Now during this transformation we need normalization. Why this normalization is required? Because the first one line, one word answer is that because of the mismatch of size. Why this normalization is required? Because of mismatch of size. That is the one word answer, one liner answer. Now if I want to clarify this, the mismatch of size, what does it mean? That is window coordinate has a different coordinate system or different referential frame. Window coordinate has a different referential frame. That is XW mean, YW mean, XW max, YW max. This is a different reference frame than the viewport coordinate. Okay, so there is a difference. There is a difference between window coordinate and viewport coordinate. So when we are going to transform a frame from window coordinate to viewport coordinate, we need some kind of transformation. We need some kind of modification. This modification is called as normalization. As you can see here, there is a shape. There is a shape in the window coordinate system. There is a shape. Now when we are transforming this frame, this total frame, not only the shape, the total frame to the viewport, some portion of this shape has been clipped. some portion of this shape has been cropped. Why? Because when we are going to transform this window frame to the viewport frame, this portion of this shape is outside of the frame. This outside of the frame. So that portion has been truncated. That portion of the shape, that portion of this object has been truncated, or that portion of this object has been cropped or clipped. This is one kind of normalization. This is called clipping. This procedure is called clipping. We will study this clipping procedure later. There are so many algorithms. There are 2 or 3 algorithms we have to study, that how we can clip the outside portion of an object for the transformation of the frame from window to viewport. How this clipping can be done. We will study 2 or 3 algorithms for that later. So now this is one kind of normalization, that is clipping or truncation of the outside part of the object during the transformation from window to viewport. That is one kind of normalization. The second kind of normalization can be total deletion of the object. Total deletion of the object from window to viewport. For an example, I am using the whiteboard. Just a second, I am using the whiteboard. All of you can see the whiteboard? Please tell me. All of you can see the whiteboard? Hello?
No, sir. Not yet.
Not yet. Okay, just wait. Actually, this Microsoft Teams. Can you see?
Yes, sir. Yes, sir.
Can you see the whiteboard? Okay. But in my portal still it is loading.
স্যার দেখতে পাচ্ছি না
এই তো এবার পাবি, দাঁড়া। এবার পাচ্ছিস কি? Tell me. Can you see the whiteboard?
Sir, please mark or draw something.
Can you see the whiteboard? I'm drawing something. You can see here. Can you see the drawing?
Yes, sir.
Okay. So as you can see, I'm drawing here. This is the window coordinate. This is the window coordinate, as you can see here. Now let's see. This is one shape we have. Say this is another shape we have. Okay. And see, this is another object we have. So this is my world coordinate or window coordinate, whatever you can say. Okay. So this is my y max. This is my yw max. This is my yw max, and say this is my yw mean. This is my yw mean, and this is my x this is my x w mean, and this is my x w max. Okay, as you can see, this is my window or world coordinate system. This is YW max, this is YW mean, this is XW mean, XW max, as you can see in the notes. So there are three objects as you can see in this window. Now I am going to tell you what is, I'm just trying to explain you what is normalization and why it is needed. When we are going to, when we are going to transform these objects of this window coordinate, in this viewport coordinate. This is, this red colored is my viewport coordinate. Say this is my viewport, this is my viewport coordinate. Okay, so now you see I'm just going to transform it, from Windows coordinate to viewport coordinate. In this viewport, how we will get this normalized view of this object. This is my viewport area. Now it will be shown like this.
And a triangle.
A complete triangle, only these two. Don't write anything right now in this whiteboard so that it will be difficult for the others to see these things. Okay. So as from the transformation from Windows coordinate or Windows area to the viewport coordinate, as we can see here, this is basically the different kinds of normalization. This is called normalization, and that's why this normalization is required. As you can see in the window coordinate, there are three objects. One is a circle which is partially inside the window and partially outside the window. A triangle which is completely inside the window, and another shape, this red colored shape, which is completely outside the window. Now when we are going to transform this window coordinate to the viewport coordinate, as you can see here, by this normalization process, this partial, the circle, a particular portion of the circle which is inside the window, that has been clipped. You can see only a single portion of this circle in the viewport, and the outside part, this outside part of this window, which is outside outside part of the circle, which is outside the window, that has been cropped here in the viewport. That has been cropped. This green colored rectangle, was totally inside the window. So when we will transform this to viewport, this triangle is totally in the viewport, but in the viewport we can see the total triangle, but in a reduced size, as you can see, in a reduced size. Why? Because viewport coordinate, that is yv max, that is yv max, and this is yv mean. As you can see here, this is yv mean, and this is xv max and xv mean. Okay, xv and xv mean and xv max. So the coordinate of yv max, yv mean and xv max, xv mean is smaller, or is these values are lower than window coordinate value yw max, yw mean, xw max, xw mean. Okay, so that's why this triangle, this green triangle, which is totally inside the window, that we can see in totality, but in different size. The size has been reduced. The size has been reduced from the window coordinate to the viewport coordinate. That is another kind of normalization. And the third object, that is this red colored object, as you can see here, this red colored object. This is already outside the window coordinate. So when we have transformed this frame from window to viewport coordinate, this object is totally omitted. This object is totally truncated or deleted in device coordinate or viewport coordinate. So this is called normalization. Can you understand this right now? Now is it clear to all of you?
Yes, sir.
Tell me, okay. So is it clear to all of you? The others? What about the others? Is it clear to all of you? Hello? Is it clear to all of you? Hello? Can you hear me? Can you hear me? Hello? Others are listening to me or not? I am audible to all of you or not? Please tell me. Otherwise, it will be difficult to continue the class. If there is no response from you, I'll stop this class here.
Sir, আমি তো শুনতে পাচ্ছি।
Okay, so please tell me because I can't see you. Only the
Sir,
voice is the
শুনতে
communication medium. Okay, that's good. Only the see one thing. Only the voice is the communication medium here. So if you do not respond to my question, I can't understand that you are listening to me or not, or you are at all present or not. Actually, so please respond to my question. When I'm asking something, please do respond. Okay, otherwise it will be very much difficult for me. Or we have to all unmute our video. Okay, so I'm just again going back to the notes. Now why this normalization is required, that is clear to all, I think. Now I am going back to the notes. All of you can see the notes?
Yes, sir.
Okay. Okay, so this is the step-by-step algorithm. What we have already discussed, what we have already explained, that is basically depicted here through the algorithmic process, algorithmic steps. That is set up viewing coordinate origin at the same world position, set up orientation of the reference frame, put set up view of vector. That is what I'm saying here. That is the normalization procedure. Compute component of U and V, that is UX UY and VX VY. This U and V are nothing but the normalization factor. Obtain matrix for converting world coordinate to viewing coordinate, translate viewing origin to world origin, and rotate to align two coordinate reference frame. This algorithm, as you can see here, this algorithm will be demonstrated by an image. Later you can see. Before going to that, you can see here device transformation using XWL, XWH, YWL, YWH. That is nothing but this coordinate we have already studied. X window, XWL means X window low. XWH means X window high. Lower coordinate, higher coordinate. X lower, X higher. YWL, that is for window coordinate, Y lower. YWH, that is for window coordinate, Y higher. যেটা আমরা বলছিলাম, what we are saying, like XW max, XW min, YW max, YW min. That is here for the easiness of writing. They have depicted here like XWL, that is X window low, XWH, X window high, YWL, Y window low, YWH, Y window high. Just like the same way, x VL, x VH, y VL, y VH. Viewport low, viewport high for x coordinate, viewport low for viewport high for y coordinate. So these are our 8 coordinates for window and viewport. Now using transformation, setup window. Setup window, as you can see in this series of image. Just follow this series of image. There are five steps. First, setup window. Listen very carefully. This viewing clipping module, this is very interesting and very easy. Questions can come in semester. Questions can come from this module as a long answer type question for 10 to 15 marks. It is very easy to solve these questions. Okay, so listen very carefully. There are 5 transformation steps, as you can see here. The first one is setup window, as you can see in this image. As you can see in this image, setup window, there is a referential frame, and we have set up the window, this rectangular frame. We have set up this window. Inside this window, there is an object. Inside the window, there is an object. Now, translate the window. Now, translate the window. That is the transformation part. What we have already shown you here. Construct world coordinate using modeling coordinate transformation. This is the first step we are explaining here. Construct world coordinates using modeling coordinates transformation. Here you can see the transformation. In the first image, as you can see within the referential graph, we have framed the window. Within the window, there is an object. Now transformation. Translate the window to the origin of the frame. Translate the window to the origin of the referential graph, origin of the frame. Okay, we have translated. Translation is a kind of transformation. So this is the transformation. After alignment, after aligning the window origin to the graph origin, we have here translate the window and align the window origin. As you can see here, we have aligned the window origin to the graph referential frame origin. That's why this translation is required. Okay, so we have aligned the window origin with the reference origin. Okay, then scale to normalize. Now we are going for normalization. Scale to normalize. Okay, scale to normalize. Why this scale to normalization is required? Because of what I have said earlier. Because of if there is any mismatch, if there is any difference, not mismatch, if there is any difference between the window coordinate or world coordinate with the viewport coordinate. If our window coordinate and viewport coordinate is same, then no normalization is required at all. Because when we do the transformation, the object will be as same as that. When in its original shape and size, it was in window coordinate, it will be same in the viewport coordinate also. If window coordinate and viewport coordinate is also same. But if this window coordinate and viewport coordinate is different, which is actually happen, in real time, we do not get any same window coordinate or viewport coordinate. Okay. Actually, in real life scenario, window coordinate is always bigger, is always larger than the viewport coordinate. So this normalization is required. Now we are going for this normalization. Scale to normalize, then scale to viewport. Now we are transforming the object along with the frame. Now we are transforming the total frame from window coordinate to viewport coordinate. From window coordinate to viewport coordinate. How this transformation, we will do this transformation? Say our window coordinate is x, that is the transformation from, as you can see here, This is the window. This is the window coordinate XWL, XWH, YWL, YWH, and this is the viewport coordinate XVL, XVH, YVL, YVH. Okay. Now we are going to transform the frame according to these 8 coordinates. XWL will be transformed to XVL. We have to calculate the difference between XWL and XVL. In the same way, we have to calculate the difference between XWH, XVH, YWL, YVL, YWH, YVH. We need to calculate the difference between these 4 sets of coordinates: XWL, XVL, XWH, XVH, YWL, YVL, YWH, YVH. We have to calculate the difference between these 4 sets of coordinates, and according to this difference, we are going to scale. We are going to scale the frame according to the viewport, from the window to viewport. Okay, is it clear? Is it clear to all of you?
Yes, sir.
Okay. So now we have scaled it to the viewport. Now everything is okay. Only now we have to shift. Only now we have to shift the frame to its actual position. Now we have to shift. Now we have to shift the frame to its actual position in the viewport. Because as you can see in this first graph, the frame was in a particular position in this window, in this window world coordinate frame. In this world coordinate system, the frame or the window is in a particular position. So now, through these 5 steps, when we have transformed this window to this viewport, at the last coordinate system to this viewport, now this coordinate is changed to world coordinate to device coordinate. The first graph was the world coordinate, and now in this last graph it is the device coordinate. So now we have to shift this frame, which is now the viewport frame. From the window frame to viewport frame, we have transformed it. Now we have to shift this viewport frame to its original position, because for the sake of this transformation, we have shifted. In the second step, we have shifted the window frame to the world coordinate origin. We have aligned the window frame origin with the world coordinate origin. Okay, we have shifted the frame. So now we have to again translate it. We have to again translate it back to its original position. So translate to viewport. That is the last and 5th step. Translate to viewport. Now this viewport frame has been translated to its original position. That is another transformation. So this is the total 5 steps for viewing pipeline from window world coordinate system, window viewport, world coordinate system and window frame to device coordinate system and viewport frame. How we can translate it. So if there is any question, anyone have any question, please ask me. If anyone have any question, please ask me up to this. Please tell me. If anyone have any question, please tell me. So all of you can understand this. This is clear to all of you?
Yes, sir.
Okay. Okay, so the others, Paras, Lalu, Suporna, Anokhi, all of you, is it clear to all of you? Okay, Ayush, is it clear? Hello? Is it clear to all of you? Okay, so if there is any question, please ask me. You can ask me. If there is any problem, any query, you can ask me. Okay. Okay, so next you can see here for 5 steps. For 5 steps, just now we have discussed. For these 5 steps, there are 5 metrics. For these 5 steps, there are 5 metrics. You need not to remember or you need not to calculate this matrix. This is just for your reference. This is just for your reference. We have to just remember these 2 equations. These 2 equations. We have to just remember these 2 final formulas. We have to just remember these 2 final formulas or these 2 final equations by which we can calculate the transformed value of Windows coordinate to or world coordinate to device coordinate or viewport frame. Okay, just I have shown you these matrices just to inform you how these equations has been generated. From this matrix multiplication, we have generated these 2 formulas. Okay, by multiplying these 5 matrices, for these 5 steps, by multiplying these 5 matrices according to these 5 steps, we have developed these 2 equations. Okay, we only need to know to solve the mathematical problem regarding this viewing pipeline or viewing reference, viewing transformation. We need to know we only need to know these 2 equations. Okay, so I am showing you some mathematical examples. Okay, as you can see here, we have the coordinates, we have the value of the coordinates of XWH, XWL, YWH, and YWL. We have the 4 sets of value XWH, XWL, YWH, YWL. That is the coordinate value of X and Y coordinate for world coordinate system or window. And we also have the coordinate values of X and Y coordinate for viewport or device coordinate system. Okay, that is XVH, XVL, YVH, YVL. We have calculated the difference between XWH and XWL, YWH, YWL, and in the same way XVH, XVL, and YVH, YVL. We have calculated the difference. and then we have put this value to these 2 equations. We have put this value in these 2 equations, and we will get the value of we will get the output result of XV and YV. That is the viewport X coordinate and viewport Y coordinate. You can see here, this is the result of XV and YV. This is the result of XV and YV for the set of coordinates. For the set of coordinates of the object XY. This object has 1, 2, 3, 4, 1. It is a polygon. There are 1, 2, 3, 4, 1. There are, you can see here, there are 4 axis points. This object is a polygon, and this polygon has 4 axis point. This polygon has 4 axis point, 1, 2, 3, 4, 1. Okay, and each and every axis point has a coordinate value, that is xy. As you can see, the first axis point has the coordinate value 1, 4. The second axis point has the coordinate value 4, 10. The third axis point has the coordinate value 8, 8. Fourth axis point has the coordinate value 8, 4. And again the first axis point has the coordinate value 1, 4. So as you can see, it is a polygon with 4 axis points. So for each and every axis point, we have calculated the transformed coordinate point. The transformed coordinate point of x and y. X, v, y, v. That is x viewport coordinate, y viewport coordinate. Using these two equations. Using these two equations, we have calculated the value of x, xv and yv. That is the coordinate value for viewport, x coordinate value for the viewport, and the y coordinate value of the viewport. We have calculated it using these two equations for each and every axis point of the polygon used here. Each and every axis point of the polygon used here. So please tell me, do you understand, all of you? The example is clear to all of you or not? Please tell me, or please write in the chat box. Please tell me the example is clear to all of you or not?
Yes, sir. Clear.
Okay, is it clear to all of you? Please tell me the others. What about the others?
Yes, sir.
Anokhi, Oyantika, Farhaz.
Yes, sir.
Okay, the example is clear to all of you?
Yes.
Yes,
Okay,
sir.
Suparna. Suparna, is it clear to all of,
Yes,
is it
sir.
clear to you?
Yes, sir.
Okay,
Yes, sir.
okay. Shubhajit, is it clear to all?
Yes, sir. Yes, sir. Yes, sir.
Okay, okay. Okay, thank you. So as you can see, this example, it is very easy to solve. This type of mathematical problem will come the semester also. They will give you a chart. They will give you a chart of these values. They will give you the chart of these values. These 8 values will be given. That is XWH, XWL, YWH, YWL, XVH, XVL, YVH, YVL. These 4 window world coordinate value and device coordinate value will be given to you. And how many axis points are there in that object or polygon, that will be given to you. As you can see here, in this polygon, in this example, they have taken this polygon. It has 4 axis points, 1, 2, 3, 4, and then again 1. As it is a polygon, 1, 2, 3, 4, and then again 1. So this polygon has 4 axis points. That will also be given to your question. So in your mathematical problem, the world coordinate system will be given, the device coordinate system will be given, and how many axis points of the polygon have, that information will be given also. Now you have to calculate. You have to calculate for each and every axis point. For each and every axis point, as you can see here, for each and every axis point, you have to calculate xv and yv. That is the viewport coordinate for each, and transformed viewport coordinate of each and every axis point of the polygon from the window view to viewport view. Okay, you have to calculate this using these two equations. You have to only remember these two equations, and it is very much easy to remember. As you can see here, xv, that is the x coordinate of the viewport. It is xvh minus xvl. That is for viewport coordinate, xvh, that is x viewport high minus x viewport low. divided by x window high minus x window low. Okay. Into multiplied by x. What is this x? Tell me, what is this x? Anyone?
given polygon point.
Anyone can tell me what is this x?
ওয়ার্ল্ড কোডের কোঅর্ডিনেট গুলো দিয়ে দিবে, ওয়ার্ল্ড কোঅর্ডিনেট গুলো দিয়ে দিবে।
Repeat it. I can't hear you clearly.
স্যার এটা ওয়ার্ল্ড কোঅর্ডিনেটের পয়েন্ট গুলো।
Exactly. That is basically this x. This x is nothing but this one. This x minus xwl, that is nothing but this one. This series of x coordinate value, the original or the actual coordinate value of the axis point of the polygon or of the object. This x is nothing but these values. Okay, is it clear to all of you? This x is nothing but these values. Is it clear to all of you?
Yes, sir.
Okay, thank you. So x minus xwl plus xbl. This is a very simple linear formula, not very difficult to remember. So this is xv, and in the same way you can see here the formula for yv, that is the y coordinate of the viewport. So this will be given to you. Okay, this will be given to you, all the values of the world coordinate and viewport coordinate, and this will be given to you, all the values of x and y, the actual or original coordinate of the axis point of the object or the polygon. These informations will be given to you. Now applying the values to these two equations, you have to find out, or you have to calculate the xy coordinate for the viewport for each and every axis point of the polygon or of the object. Okay, so is it clear? Is it clear to all of you? The example, the mathematical problem is clear to all of you?
Yes, sir.
Okay, thank you. So that's all for today. We will end the class now. So if you have any problem regarding the any query or any question you have,